Hi, everyone. This is a beginner's guide to hacking electronics to display Grafana dashboards. My name is Yonatan Mevorach. I'm a developer at Wix.com, and I'll tell you a little bit about my skills. If I might say so myself, I'm really good at sitting on the couch and watching Netflix. I'm okay-ish at using JavaScript as the main programming language that I use in my day-to-day work. And up until recently, I knew almost nothing about electronics or how to hack electronic devices. And we're going to see why that became an issue in just a moment. At Wix, we use Grafana to keep tabs on the majority of our services, and we have a lot of them. We use alerts a lot because since we have so many services, we really want to be notified about the ones where there's an issue, when there is an issue, so we can catch it and prevent any actual problems for our users. Earlier this year, my team launched a new service. This is the initial dashboard that we created for it. And we set up some alerts for it, but we weren't yet sure exactly what exact metrics to put alerts on, what limits specifically to put alerts on, because this service was brand new, but already getting traffic and people being relying on it. So we wanted to keep an extra eye on it just for that first week until we can fine-tune all the alert settings. Now, to do this in our offices, we have these dedicated monitors up on the walls that we can cycle through a few Grafana dashboards. And while we're working from the office throughout the day, literally keep an eye on our data. Now, the thing is that when we started rolling out this particular service, we weren't working from the office because this was exactly when COVID hit and we were starting to work from home. So one day as I was working from home, I looked around my desk and I thought I really miss having this extra monitor just for Grafana, especially at this crucial time for this new service. And I noticed that I have this mini arcade machine branded as from Wix Engineering that we got from one of our internal conferences. And honestly, it was just collecting dust on my desk because I'm not much of a gamer and I really didn't have much use for it. And I had this eureka moment when I thought, this already has a screen, a small one, but still it has a screen. And it's already kind of within the area where I can glance over at. So I thought this would be really cool if I can convert this to not be an arcade machine for games, but as a second Grafana monitor. If you're wondering, by the way, about the rest of the things on my desk here, this is my boss. So I thought I really want to transform this this arcade machine into a Grafana dashboard, but I really had no idea how I can achieve something like that because, this was designed by the manufacturer to do one thing, and how do I convert it to do something else? So at first I thought that, it's a nice idea, but it's not really realistic. But it was kind of like a bug stuck in my head, and I decided to try anyway. One of the things that I had going for me is that a few of my coworkers also had this mini arcade machine because, like I said, it was swag that we got. And a few of them weren't using it as well. So they were fine with me taking some of their machines home and just tearing them apart just to see if I can kind of guess my way through how they work. So that's what I did. So what you're seeing now is what I saw on my desk after taking a machine apart, just laying out the components on the table and trying to understand what they do. So I encourage you to kind of think like I did and try to see if you can guess what each component does. So this is the screen. I also know from where I pulled it from that it sits right where the screen sits. So this is what we use, for the display. This board here with the red physical buttons that you can see sits right below the actual buttons of the arcade machine. So I'm going to assume that this board is in charge of the interface with the physical buttons. This complex controller here, or CPU, I'm not exactly sure how to call it, was just inside the machine. So I'm assuming this is the brains behind the whole thing. This kind of controls the game logic and everything. And finally, we have the battery compartment because this arcade machine is portable and powered by batteries. So just by kind of taking a look at all these components, I can already plan ahead and think which components should I try to kind of reuse and which I'm going to have to replace. I want to maintain the original experience of the user experience of the arcade machine. So I want that nice classic plastic exterior. I want the buttons to work. I want the screen to work. About the parts that are inside, I can't reuse the original parts because it's going to be very difficult to understand how to reprogram the original CPU that came within the machine. I'm not going to be able to use the original power supply because I don't want to be limited by batteries. I want something that will be always on. And obviously, the original arcade machine couldn't connect to the internet, so I would need to find a solution for that as well. I thought about this a bit, and I remembered a project that I think that a lot of people are aware of, even if they haven't had the chance to use it, which is the Raspberry Pi project. The Raspberry Pi project started a couple of years ago as a low-cost hobbyist computer that is specifically designed for these kind of maker projects. And I knew that it's meant to be programmable, so it can something that I can write code for and program. It can be the new brains of my machine. It connects to power via USB, so it can be always on, and it can power other electrical components that I connect to it. And it has access to the internet via Wi-Fi, so that solves that as well. In terms of the form factor, you can see from the comparison to the size of the coin here, it's very small, so it can fit within the original machine and maintain the original form factor. So now that I had this overall plan, my next plan was to have these series of small proof of concepts to kind of see if I can bridge the gap between the Raspberry Pi and the parts of the arcade machine that I wanted to reutilize. So I started with the controls, the buttons. I took a closer look at the board that the physical buttons are connected to. And you can see I have 9 buttons. I know what they do because of their physical location and the label that's on the exterior plastic of the arcade machine. And you can see each button is connected to one of these pins in the middle via a light green path that's printed on the board. Now, the pins in the middle is how this board is connected to the main controller board via a cable inside the machine. So by following this light green path on each of the buttons, I determined that each pin is associated with one button. Except, as you can see here, there's a mystery button that's not connected to, a mystery pin that's not connected to a single button, but rather is connected to all the buttons via the perimeter here, the light green path as well. So after a bit of Googling, I realized that this is the ground pin that completes the electrical circuit. So if I take a look at the Raspberry Pi and how it's meant to be connected to an interface with other components, it's via the pins that are on the Pi itself. Each one has a number, and we have these guides that tell us what is the responsibility of each pin. And if you Google like hello world examples of connecting a Raspberry Pi to a button, any button, you realize that the straightforward way of connecting it is connect one pin on the button to one of the GPIO pins, general purpose input output pins on the Raspberry Pi, 36 for example, and connect the other pin of the button to the ground pin, number 30 for example, a dedicated ground pin on the Raspberry Pi. So that's in terms of how to connect it. In terms of the software that we would need to write to respond to a button click, like I said, I mainly use JavaScript. You could do that with the Raspberry Pi as well. There's lots of libraries for controlling the Raspberry Pi on NPM, the package manager for JavaScript. I chose one which is called RPIO. So this is how you would use RPIO to respond to a button click. First, you would import it, initialize it. You would tell it which pin on the Pi you're kind of listening on and using as an input pin where the signal needs to be received. And you register with the poll method a callback that you want to have called whenever a signal comes in on that pin. And that within that, you can do whatever you want. If we're just demoing it, so let's say console log that the A button was pressed. So now that I knew how to connect things physically and also what to do on the software side, I put it all together into one of the first POCs that I would need to do. I'm connecting via alligator clips, detachable, the original controller to the Raspberry Pi, running this program. And as you can see, when I click the physical button, it logged out A was pressed. All right, so the first POC is a success. Now I'm going to take a look at the screen. I thought about it for a little while and realized that I want to take a shortcut. I don't want to try to understand how to reprogram and what is the interface for the original screen that comes with the arcade machine. So I decided instead to find an alternative LCD screen, which just had to have the same form factor. So I measured the original screen, it was 2.4 inches, and I found a LCD screen 2.4 inches that's meant to be exactly used for hobbyist projects, and therefore it's well documented how to connect it to the Raspberry Pi and how to interface with it in terms of code. This is by a manufacturer called Waveshare. In their website, they have a guide exactly explaining which buttons on the LCD, how they should be connected to which pins on the Raspberry Pi. And they also provide a library which you can use in your code, a higher level library where you can like give it an image and it will display it. Now, there is just one problem with this code. And if you remember kind of the things I told you about myself, it should pop up and be instantly recognizable. And that is, this code is in Python. And like I said, I mainly use JavaScript. I want to stay in my lane. So I know that I described using this LCD as a shortcut, but now I want to take kind of a detour and not use the original library that the manufacturer provided, but rather write my own JavaScript port of it. And this helped me understand a little bit about how these display drivers work behind the scenes. So this is the code of the display driver, not the API of how you would use it, but actually the code of the API driver or the driver itself. And for example, you can see that some of the things that they do here is they just send raw hard-coded bytes. For example, when you call the init function, it sends raw hard-coded bytes to the Raspberry Pi. So when I wrote my JavaScript port of it, I basically did the same. You can see it's the exact same values. And these are, this is the low-level way that you interface with the device, and it just expects these bytes in order to go into, for example, the init mode. The things that were more interesting about porting this code had to do with understanding how we convert our image to something that the low-level driver can actually transport to the actual component and display. So let's say that we want to display this image, a solid color image for simplicity, a solid red image, and let's say that it's 320 pixels by 240 pixels. So this is how we would typically want to encode this. So we're having a buffer here, and let's see why this is the buffer that represents that image. So first of all, each of the items here is a hex representation of the color red. And you're probably familiar with this representation, especially if you're a web developer, because it comes up a lot. This model is called RGB 888. And why do we have 76,800 of these? Because we have 320 pixels by 240 pixels, and we need to pass each pixel in this for this size. So looking at the code of the original display driver that in Python that the manufacturer provided, I saw that one of the things it does is it takes this bitmap representation of our image and it converts it to this bitmap representation. And instead of serializing each pixel to 32 bits, it's using only 24 now. And this is because a different color representation model, which is called RGB 565. So this is an example of a transformation that has to be done inside the display driver before we actually transmit this buffer to the LCD. I published this new library under NPM, unrelated to Grafana or all that. You can check that out on its own if you want. So this is how you would use this new library. All right, so we're importing RPIO again. We're importing this new library, which is called the 9341 LCD. And we're using a library called PNG.js to convert a PNG image, which is the original image that we want to show, into a raw bitmap, like I mentioned earlier. So we're reading the data of the PNG. We're converting it from a PNG to a raw bitmap, initializing RPIO, initializing the display driver, actually calling the init method, and we're passing the bitmap to the show image method. Once we do that, we can load up any PNG from our code, connect the LCD to the Raspberry Pi, and have it be displayed. So our second POC is also complete. Now, the third POC that we needed to do is to actually get data from Grafana. This is a major part of our project. Luckily, I realized that there's an API in Grafana meant to render static images of panels at any point in time. You do this with a simple HTTP GET request. So let's go over the parameters that you would need to pass. So the endpoint is called the render endpoint. You give it the identifier of the dashboard that you want to render. Each board is composed of panels, so you need to pass the ID of the panel that you want to display, because what we're trying to do here is render each panel as a static PNG. You need to tell it the time frame, because if you're rendering a panel, you need to tell it how many minutes or hours to kind of give you in the range. And since we're actually going to render it to an image, we need to tell it the dimensions of the image in width and height. Because we're not calling this from a browser, you need to authenticate into Grafana somehow. So you give it your API key with the authorization HTTP header. All right, so now that I had everything together, I'm able to listen to the button clicks. I'm able to show stuff on the screen. I'm able to get data from Grafana that I will show on the screen. I need to put it all together. Now, up until now, all the physical POCs that I did with detachable wires to connect components. In my permanent project, I want it to be permanent, and I don't want it to fall apart. So I want to put everything together. So I'm using solder iron and solder to actually wire the components together. So before I do that, I need to plan exactly and make note of how I'm going to connect things, because there are going to be a lot of wires involved, because we have 9 buttons and the ground pin on the buttons on the controls. So we would need to connect each one of those to the Raspberry Pi. So I'm just finding free GPIO pins on the Pi and making note of the number of the GPIO pin that I connected to, because I would need to reference these in my code so that I can distinguish which button was pressed. I'm connecting the LCD to the Raspberry Pi based on the instructions of the manufacturer. So this is my plan on how I'm going to connect things. And now it's time to do it for real in actual hardware land. So I'm using a soldering iron. I Googled how to solder, watched a bunch of videos. It's not very difficult. You just have to be careful because it can get quite hot. And connecting the wires to the pins that I planned ahead. Now I'm taking one of the machines apart and removing the parts that I don't need, like the original screen and the battery compartment and all that. I'm exposing the wires on the controls board, and wiring everything together to the LCD and to the Raspberry Pi, using a hot glue gun to put the LCD in place, putting the screws and putting everything back together. And now I'm really happy to share with you my Raspberry Pi Grafana arcade machine. You can see I can use the buttons to cycle through graphs, and they also cycle through automatically every 30 seconds. Thank you very much for listening. This is my blog where I have a dedicated blog post about this project with some more info if you want to check it out. And I'd be happy to take any questions that you might have. Thank you. All right, hi everyone. Thank you for watching. I'll just get into the questions. All right, so one of the questions was, what's next on the hack list? Any other non-computer items in your future on your future can it run Grafana list? So like they say, it's an excellent question because I have an answer for it. I recently picked this up. This is an e-paper or e-ink display from the same manufacturer, Waveshare. It's too big to fit inside the arcade machine. But what's neat about this is that it works in direct sunlight and can stay powered for a very long time on a battery, just like a Kindle. So I think it will be really cool to have something like battery operated or solar power operated and still be able to kind of see graphs and see what's going on with our metrics that I care about. The story of the boss on my desk. I can assure you that it's not real. I don't really have a picture there of my boss. I just did it to take a picture of my screen. Can you share the code for the Raspberry Pi? I am planning. There is a blog post that goes into the hardware, pretty much identical to what I went through now in the talk itself. I am planning a future post explaining the hardware. And yeah, there's a very good chance I'll put it up on the GitHub as well. I'll explain just a tiny bit about how it works. So there's a great open source library called XState, which is a library for modeling your code as a state machine and the transitions between the states of your state machine. I heard about it from the community of React, so people use it to model UI, but I think it really shines in places like this where there's no UI. So if you think about it, the output is the screen, and the input is the buttons, and based on what the screen is, each button now has a different responsibility because we only have a few buttons. So I map all this out as a state machine, and I just give it to the node script, and then it already enforces like all the rules of what buttons does what whenever the screen, according to what is displayed on the screen. Another question was, how long did it take you to do the whole project? Obviously, in talks like these, you're kind of explaining everything after all, you already figured out all the stuff that kind of blocked you in the beginning. I didn't work on it, in a linear way. I kind of dropped it and went back to it when I had the chance. But I would say a few weeks, but it was very rewarding. And that's it. I think that's the last question. So thank you for watching, and enjoy the rest. Thank you.